We're talking scatter plots. Here's the little fun is these are supposed to be like scattered little dots as I wrote that, and that's so fun. All right, we're going to interpret this graph of scatter plots that shows the amount X in gigabytes of RAM and the prices Y in dollars of 10 laptops. So let's actually check this out real quick. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. Okay. So these are 10 individual laptop prices, okay? It says, what is the price of the laptop with a RAM of 12 gigabytes? Well, with that information, we can have a really specific outcome. So we can just look, and it is $800, okay? So 800, right? What is the RAM of the $1,400 laptop? Well, let's see. Here is $1,400. It is 16 gigs. Now, what happens to the price as RAM increases? This is where we're actually getting into interpreting this stuff. And I'm pretty sure you might know this information just because you've bought an iPhone or have thought about it before, that the RAM price, as the amount of RAM goes up, the price goes up. And if you're like, how is that? Well, I mean, look, if we were to connect these dots, I would say that's a pretty good representation. This red line that I just drew, let me erase this red line so you're not confused. That red line seems to be a pretty good representation of what's happening to the price as that happens, right? So to put it in words, increases, duh. Number 2, the scatter plot shows the earned run averages and winning percentages of 8 pitchers on a baseball team. So just like last time, 1, 2, 3, 4, 5, 6, 7, 8. Cool. So, and if you're like, I don't know what earned run average is and win percentage, I think we'll be able to figure it out still, right? What's the winning percentage of the pitcher with an earned run average of 4.2? Earned run average 4.2. Well, let's see. That would be 4.5. That'd be 4.25. So let's follow this up. Yep, that looks to be about him right there. So him or her, I guess. 6.6 is their winning percentage. 0.6. What's the earned run average of the pitcher with a winning percentage of 0.3333333? There's 0.3, there's 0.4. So again, we're going to kind of go in the middle there. All right, it is 5. Okay. What tends to happen to the winning percentage as the earned run average increases? So as this increases, as this is going this direction, it would appear that things are going like downwards, right? So if you have a higher earned run average, you're not winning as much. So the winning percentage decreases. Number 3, describe the relationship between the data and the scatter plot. Well, it appears to basically be going in this direction. We call that a positive linear correlation. And if you're like, why do we call it that? Well, positive, think about slope. This is going up and over. We are going up the mountain. That's positive, right? Linear because it's a line, and then correlation because that is essentially the way we're communicating just the relationship between the X and Y values of these dots. It's pretty much a vocab term. Describe the relationship between the data and the scatter plot. Well, this one's tough because do you put it like that? Do you put it like this? Well, if you're having trouble figuring out, it is because there is no correlation. There's no real way of figuring out what the heck is going on there. Describe the relationship between the data and this scatter plot. Now, here's where we might start to argue some because you might say, well, listen, I think that is pretty strong right there. And I don't know, because what about these guys down here? They're really far down there. I mean, so it would really kind of maybe drag it to look more like this. But then if you did that, I'd be like, well, what about this guy and this guy? And still, that seems pretty far away. So I'm again going to go with no correlation. It's just too scattered. Number 6, describe the relationship here. Now, this is where, okay, that seems, and maybe that's not very good, but that seems a little bit better. This has a negative linear correlation. And if you don't agree with like the no correlation ones, like let's zoom out and let me erase, some of my dots here and erase these dots and erase these lines and whatnot. And just like compare now that they're all kind of on the screen together. This seems pretty obvious that it's going up in that direction. This one seems pretty obvious it's going down that way. That one still is arguable, but I'm going with no because of our giant and numerous outliers, and then this one is pretty obviously no way, Jose. Make a scatter plot of this data. Okie dokie, 3.1 and 1. All right, well, pay attention to the scale of your graphs always. So 3.1 would be right here. 3.1 and 1 is right there. Done. 2.20, 2.20, done. 2.5 and 1, 2.5 and 1, done. 3.7 and 2, 3.7 and 2, done. 3.9, we're at the very edge of the graph. No, maybe not the very edge. We're right here. 3.9 and 0, so right there again. 1.5 and 2, 1.5 and 2, done. 2.7 and 3, right there, and done. And last is 2 and 2, 2, 2. Now describe the relationship between the data. This one, I don't know. If I try and draw a line like that, we've got this guy's pretty far out. These guys are pretty far out. And if you do it like that, again, that's pretty far out. That's pretty far out. I'm going to go with, since I'm having such a hard time with it, I'm going to go back with no correlation. Like, I think that's a decent argument to make if you're really conflicted to drawing a line. If you're really conflicted about the evidence of a strong relationship, then just say, no, we don't have one. Number 8, the table shows the total amount Y in thousands of dollars of money a homeowner saves on electric bills X years after installing solar panels. Okay. Write an equation that models the total amount of money saved as a function of the number of years after the solar panels were installed using these 2 points. You got it. So what we got to do is we're going to find our slope, which is y2 minus y1 over x2 minus x1. So 10.5 plus 12 is 22.5 over 15. And you know what? I'm going to leave it like that for right now. Because, well, yeah, okay, hang on. I guess I could, if I were to multiply that by 10 over 10, I would get 225 over 150. And let's see, could I divide those by 25? I think I can. So let's see, 225, that's 25, 50, 75, $1, $2. This is 9. And then this is 6. Divide those both by 3, we get 3 over 2. So interesting, that right here it seemed like, ew, yuck, but now it's just 3 over 2, right? Okay, coming back, so we have our slope. It's 3 over 2, and we want to use these points to write an equation, and it doesn't say which type of equation we should use, whether it's point slope form or slope intercept, so I'm going to do both. Just for you guys, y minus negative 12 equals 3 over 2 times x minus 0. This is one good answer. Now, this is obviously a computer type thing, so you might want to simplify this to just be y plus 12 equals 3 over 2 times x minus 0. And even then, you might want to get rid of that part. I don't know. And really, if you're going to do this one, which I'd recommend because it has the 0, maybe just keep going and now subtract 12 to get this, right? So now I give you my second acceptable answer. And then my third acceptable answer is y minus 10.5 equals 3 over 2 times x minus 15. And then just believe it or not, that does end up being that. So here are your three acceptable answers with stars next to them, okay? And then it says, interpret the slope and y-intercept of the line of fit. If you didn't know, that's what we were just finding, is the line of fit, okay? So what does all that mean? Well, based off of this info, the total amounts of money saved is y. So y is money saved, and x is years after installing, okay? So it would appear that you save, I could say $3,000, so 3K, $3,000 every 2 years. If you wanted to get real picky with it, you could say you save $1,500 per year, because that would be every 1 year, right? That would be if you reduced this to being 1.5 over 1, but you don't have to do that. And then the other part is the y-intercept, is that technically from right here at negative 12, it means that it looks like it costs you. So y-int of 12 or negative 12 is it must cost you 12K to get solar panels. Interesting. So last one, your friend says that a line of fit must pass through at least one of the data points. Is your friend correct? No, not necessarily. And I know that seems a little crazy, but it doesn't have to. I mean, you could have points like this, and that clearly has a positive correlation, and I'm kind of doing my best here. But imagine, that it looks like that. I mean, theoretically, that is not touching any of my points. Look, there's clearness in there. There's white between there, right? So the answer is no, and your explanation is it really just doesn't have to.